Marajaw na adlaw, everyone. Good evening, Jack and Ryan. Our topic for this evening or today is robotics and artificial intelligence. So this is just an introduction about robotics and slight information about artificial intelligence. Robotics is an interdisciplinary sector of science and engineering dedicated to the design, construction, and use of mechanical robots. Our guide will give you a concrete grasp of robotics, including different types of robots and how they're being applied across industries. Again, robotics is the intersection of science, engineering, and technology that produces machines called robots that substitute or replicate human actions. If you have seen like the movie Chappie, what else? Do you know movies which involves robot, Ryan and Jack? Can you give me a title of a movie?
iRobot, sir, tapos Robocop,
Robocop. How about you, Jack?
tapos si iRobot.
Terminator, sir.
Oh, very good. So those are the things are those are example of robots in the near future. Maybe we could actually see them. What is a robot? A robot is a product of robotics field. From the word robotics, so the result is a robot, where programmable machines are built that can assist humans or mimic human actions. Robots were originally built to handle monotonous tasks like building cars on an assembly line. Okay, mostly robots nowadays. When you know that Ford, Yamaha, Toyota, for sure they're using assembly robots. The ones that the design is more like a hand, and then on an assembly line it transfer into one place to another in order to make a one fine car that you like. Like let's just say Fortuner, Montero Sport. Okay, welcome Judy. So those are example. The image we carry in our mind. So what we always visualize about a robot is that um ro- in our minds about what robotics and artificial intelligence are usually polarized. For many people, what we think of robots is likely influenced by popular culture, movies, books, or comics, di ba? Many people imagine robots like Star Wars droids. If you have seen R2D2, okay ra Jude. R2D2, tapos Wall-E, if you have seen the movie Wall-E of Pixar's, or at the other end of the spectrum, something like humanoid, AI-enabled robot, virtually indistinguishable from humans from the movie Ex Machina. So have you seen the movie Ex Machina? So if you have time, you can watch that to see what
No,
the robot. Okay. So robots are usually defined as mechanical devices capable of carrying out tasks they have been designed and programmed for. Many different types of robots are used in manufacturing. So I've said earlier, mostly cars are assembled because of robots. So the people will just intervene when it comes to something like quality assurance, um
Transformer na, sir, ay nakalimtan na ako ba da?
yeah,
Transformer.
Transformer is one of the most complicated robots that you can see because they come from the other
Alien.
planets. Yeah, alien planets. Okay. With tasks ranging from repetitive moves on an assembly line to other tasks that may be dangerous for humans. For example, due to high or low working temperatures or radiation. As in this statement, it says that usually robots replace humans because of how dangerous the works are. Like for example, very crucial heat. So we cannot stand heat like more than 50 degrees because it's too far from what we always experience like 27 degrees Celsius, or from low temperatures working on an ice plant. or radiation, especially radiation. If you're overly exposed in radiation, if you have seen 100, the 100 in Netflix, so that's one example of how dangerous radiation is. And of course, nuclear weapons has radiation. And you've seen documentaries. Most people that are exposed in radiations are mostly killed right after how many days because of the exposure. That's why we need robots working on these conditions. Now, we always associate AI or artificial intelligence when we talk about robots, right? So we are already imagining that without also AI, which can be the program of robot, it will not work well according to its task or design program. Now, artificial intelligence is the branch of computer science. So branch of computer science, always remember, which deals with developing complex systems that try to emulate human intelligence in response to new and changing situation. So AI tries to emulate, from the word emulate, as we talked yesterday, emulate human intelligence in response to new changing situation like voice or face recognition. So we can identify voice. Uy, that's the voice of Ryan or Judy. So robots can also identify that one, or the face recognition, problem solving, or natural language processing. There are a lot of AI approaches now. Like if for natural language processing, if you're familiar with Siri, with Alexa, with Google Assistant, where you will just say the invocation keyword like, "Hey Siri, okay Google," or Alexa, in which the natural language processor can identify those keyword and execute the things that you speak before it. Like for example, "Hey Siri, open Facebook." So Siri will open Facebook. Okay. Okay, pata. Still up, guys?
Yes,
Yes,
sir.
sir.
Daan kan
Yes,
Iron Man, sir.
sir.
Dan Jarvis ni da, sir. Si Jarvis.
Yeah, that's an AI. Jarvis is an AI. So
Kay
it can
Iron Man, sir,
identify.
di da matawag robot.
Yeah, robot. But the system itself, Jarvis, is an AI, so it can actually identify the voice of Tony Stark and processes those requests like Jarvis, yeah, request. Okay, like for example, hala, can you see this one? If I say, "Hey Siri, oh, open Facebook,"
On it.
but the response of mostly of these applications
Something went wrong.
will
Please try
depend
again.
on the internet itself connection. So that's why we often hear an error like trying to connect. Those are but in my house I have Alexa that I paired it with my project. So I would just say, "Alexa, play reggae." "Alexa, play EDM, play Ben and Ben." So it will execute and play the music. Okay, Judy, are you there?
Yes, sir.
Okay, Jack, Jack, Jack,
Yes,
and
sir.
Paul.
Diyan na, sir.
Okay, good. Next. So one of the most important things to learn about robotics is the Isaac Asimov's three laws of robotics. So there are three governing laws for robotics. So when you make a robot, there are corresponding protocols for that. You cannot just make a robot without considering these three laws. So this is universally accepted, and every developers knows this one. Like for example, for the first law of robotics, a robot may not injure a human being or through inaction allow a human being to come to harm. So if you will make a robot, so if for example Ryan will build a robot, he should make sure that it will not harm any human, like just target humans. If you will
Na
equip it
kung
with
kuhaon
guns.
ka mo sa gobyerno, sir, tapos pahimuon ka mo ng mga soldier. Mapalag
That's
pa ka.
that's another story, but we pray that it will not come to that point. But as again I've told earlier, so your robot must not hurt any human, like it will slap Judy, so it should not happen. For the second law, a robot must obey orders given it by human beings, except such orders would inflict the first law. So the second law states that the robot should adhere to what everything you say. Like if you will say to the robot, sit down, so the robot must sit down. Stand up, the robots should stand up. But there are exceptions for that. Your order must not conflict with the first law. So, like for example, robot slap Judy or slap Ryan, punch Jack. So that should not be the thing or the program you will give to your robot because it will already violate the first law. Now let's proceed to the third law. A robot must protect its own existence as long as such protection does not conflict with or first or second law. So there's a consideration for the first and second law already. So the robot also must protect its existence as long as it does not violate the first and the second law. So as long as it will not hurt human, and that's the main concern of building robots. So again, it's Isaac Asimov's three laws of robotics. You should be familiar with these aspects because this is really important. As until now, I can still remember this topic from our robotics class when I was still in college. So it's not easy to define what robots are, and it's not easy to categorize them either. Each robot has its own unique features, and as a whole, robots may vary hugely in size, shape, and capabilities. So the robots are not in the same in terms of its size because there are huge robots. For the shape, there are square, there are circle robots, and of course, the capabilities. So robots differ from as to the extent of its features on extent of its capabilities to do tasks that you are about to tell them or program them. Still, many robots share a variety of features. Here are let's disregard that. Here categories to classify robots. So for the types of robots, so there are categories that are used to classify robots. So for the types of robots, take note ha. For aerospace, are you familiar with aerospace? Tut, tut,
Yes,
tut,
sir.
tut, tut. So aerospace involves outer space from the word space. So aerospace, this is a broad category. It includes all sorts of flying robots daw. The smart bird, robotic seagull, and the raven surveillance drone. For example, but also robots that can operate in space daw, such as Mars rovers. Are you familiar with Mars rover? The one that those rovers that are sent to Mars, right? If you have seen in the television or in the news, rovers in Mars looks like a small robot, but in reality, it's very huge, very very huge. And NASA's Robonaut, the humanoid that flew to the International Space Station and is now back on Earth. So first one is from aerospace. So let's see what are the example of this aerospace type of robots. So these are the aerospace robots. So includes as you just have to remember the term flying. So again, mostly as you can see, can you see this picture? Guys,
Yes,
can you
sir.
see it? Okay. So they usually drone flying robots are used for like research, for surveillance, and when it comes to aerospace, it helps them especially when a robot is fully AI equipped. So they can help in structuring structuring aerospace like shuttles, monitoring. So they are really important when it comes to aerospace. Now we also have consumer for the consumer sector. Consumer robots are robots you can buy and just use for fun or to help you with tasks and chores. Examples are the robot dog, Aibo, and Roomba vacuum. AR-powered robot assistants and growing variety of robotic toys and kits. So from the term consumer, you can actually buy robots nowadays. So like the next picture will allow you will let you see or realize that these are robots that I can really buy. Like for example, this one. So this is the dog. I think you can actually tell this dog the common things that you will always say to your dog, like fetch. But I'm not really into this dog Aibo. But if you have seen that this picture here, can you see this one? This is a vacuum cleaner. So if you have browsed already in your Shopee cards, so vacuum cleaners are already market available. So you can buy these types of robots in the market. Most of them, there are those that are less than 1,000 pesos. So you can actually buy a consumer robot nowadays. And then you can also buy robotic kits. So usually I have here mga robotic kits that I can use and study so that I can create my own and program my own robot. That's why I've started this passion like starting 2017. So it's almost it's 4 years now that I've engaged myself into robotics already. Aside from the college exposure that I have. Okay? Thumbs up if you're still there.
Yeah, may hands up sa ako, sir.
More hands up. Or hands down na kan. Okay. Wow, it's type 1 in the chat box. Wow, 1. Okay. How about Jack? Nice, Jack. Okay, let's proceed. Now we proceed to the disaster response. Okay, from the word disaster response. So if we hear these terms, it's all about rescue, right? So these robots perform dangerous jobs like searching for survivors in the aftermath of an emergency. For example, after an earthquake and tsunami struck in Japan in 2011, pack boats were used to inspect damage at the Fukushima Daiichi nuclear power station. So actually, these are the robots that I want to build in the future. So I'm already planning. But the only thing here when you build disaster response robot is the cost of making one. So maybe in the future I will have the budget and I can already create and contribute to the disaster risk reduction. Of course, response because there are robots now who that has thermal imaging scanning. So you cannot just dig the cements or collapsed building. So you need to scan it with temperature sensitive sensors so you can see that there are still survivors like beyond that wall. So that's actually my vision when it comes to robotics. Now, these are the examples. Oh, as you can see, we have here a robot inside a collapsed building or on a trap building here running on the stairs and this one. So it's really good to have this knowledge about robotics. So if you want to build one in the near future, that would be a good one. Okay, next. If Marvin if Marvin was here, so drones. Are you familiar with drones? Of course.
Normal drone, sir. Sir.
Yeah, normal drone. Marvin has one. Drones, also called unmanned aerial vehicles. So drones are usually called unmanned aerial vehicles or UAV. Drones come in different sizes and have different levels of autonomy. Example includes DJI's popular Phantom series and Parrot's Anafi, as well as military systems like Global Hawk used for long duration surveillance. If you have seen like movies, military movies, so they actually target a certain area where there are terrorists using drones. So it can already drop bombs into that area, and in a specific radius, it can destroy or destruct your facility or kill people. So these are examples of drones. So
Robot bang drone, sir?
yes, drone is a robot. So actually, robots,
Naka-harman siya. Gigamit sa kuan military.
ha, Jack?
Naka-harman siya. Kay gigamit sa military mga airstrike nga na. Valid
Oh,
pwede rin gapon.
oh,
Mo-conflict.
actually, kuha man siya, makaharm, makaharm humans, but the ones that they are harming are those who has also plans to harm people. But again, robots in the ASEAC, I think three laws of robots, you should not harm humans, but they don't have the choice, mostly for military vehicles, because there are orders from above, especially presidential's order that you need to bomb this place. But one thing, guys, they cannot just bomb a certain location. If there are innocent people involved, actually they can be sued for that and court martial. So there are a lot of case now. Even if you see the movies, drones are not actually intended to kill people, just for surveillance. But nowadays, na people are raging wars from one another. So for me, it still violates the SAX 3 laws of robots. So, but we cannot do something about it because it's military execution. But we just have to buy this drone, Jack. Don't use this one. Just the Phantom series or DJI Mavic or DJI Mini Pro or Mini 2. Okay, let's proceed. There are robots also used for education. This broad category is aimed at the next generation of roboticists for use at home or in classrooms. It includes hands-on programmable sets from Lego, 3D printers with lesson plans, and even teacher robots like EMIS. So actually, for education, these robots in other countries they have this type of robots. You can assemble this one. So it's module, like the wheels are separate, the body are separate, this one is separate. Actually, if you're familiar with Lego, right, you just have to attach it from one piece to another. So there are those robots that are Lego based. So you can attach itself here and also connect wires already, and you can form this type of robot. And for the programming, they have a set of software. So it's robot specific software that you can only program the ones that they have manufactured. And if you're familiar with 3D printer also, in the middle, so it can actually um print, like if you want to print an anime figure, if you're familiar with Luffy, with Sanji, with Tony Chopper. So using 3D printer or maybe your face, through a 3D modeling software, you can print your ideal figures using the 3D printer. And this one is a teacher robot. So basically, it's programmed to teach people, like especially the students. So it can teach various subjects, math, science. So these are educational robots. Now also there are for entertainment robots. So these robots are designed to evoke an emotional response and make us laugh or feel surprised or in awe. Among them are robot comedian Robotics Disney's theme park robots like Navi Shaman, and musically inclined bots like Partner. So these are entertainment robots. So for you to visualize this one, actually they can entertain you. So I think this is Robothespian, comedian robot, and Disney's theme park. This one is a robot also. If can you still remember what movies is this one? What's the
Avatar.
title? Yeah, Avatar. So the design is more like an avatar. And musically inclined bots like Partner. This one, it can play trumpet. Or I think this is not a trumpet. This is specific, but I don't know the name. So these are entertainment robots. So you have already a lot of ideas about to the types of robots, and there are still a lot like this one, exoskeletons. Exoskeletons, exoskeletons can be used for physical rehabilitation from the term physical rehabilitation and for enabling a paralyzed patient walk again. Some have industrial or military applications by giving the wearer added mobility, endurance, or capacity to carry heavy loads. So these are the example. So actually, it supports your body from the term exoskeletons, the bones, because you cannot just stand it for yourself, especially for those who have undergone a paralyzed event. So they use exoskeleton, but I think in our
Kamara ni Sir
country,
kan Robocop Sir.
oh yeah, it
Kaso
RoboCop
kay
has
Muraton
support.
tanan.
Yeah, sa feet, sa hands, and what else? Tomorrow's War. If I'm not mistaken, they use exoskeleton to support bones. Okay, body weight. So it carries your body weight.
G.I. Joe. To sa G.I. Joe Sir.
Yes, G.I. Joe. Grabe, Ryan. You have a lot of movies. Okay, next. Humanoids. This is probably the type of robot that most people think of when they think of a robot. So, actually, this is the basic visualization of people about robots. Humanoids. Examples of robots include Honda's Asimov. If you're familiar with Honda's Asimov, which has mechanical appearance, and also androids like Geminoid series, which are designed to look like people. So robots from the term humanoid. So it's human android. So it's more like the robot is looks like a human. So these are the example. Actually, this is the most famous when I was still like siguro mga elementary until high school until college. So Honda developed this kind of robot. Uh, they look like human, but actually they are robots. Okay. Judy, are you there?
Yes, sir.
Oh, very good. Jack,
Yes,
still up?
sir.
Okay. Ryan,
Diyan ako Sir. Takabidaan Sir.
still. Nice, nice. I'm really glad that you're still here. Next, industrial. The traditional industrial robot consists of a manipulator arm designed to perform repetitive tasks. An example is the Unimate, the grandfather of all factory robots. This category includes also systems like Amazon's warehouse robots and collaborative factory robots that can operate alongside humans. Okay, so for example, this one. Actually, as I've read earlier, Unimate is the grandfather of all factory robots. By saying factory robots, there is some sort of assembly line. Like, if this is just like an arm, right? That it can um, point from one place to another. If you can see my hand, so it will just put like objects or next to assembly line. So it's Unimate. If you have also seen Amazon's warehouse, these are robots that can actually deliver things from one shelf to another. So I don't know how they made this one because there are a lot of these things in their warehouses that can automate delivery of items there. So which makes their jobs or their processes a lot easier. Okay, and of course, factory robots like this one. There are two arms here from one to another, so which is a good thing because it actually reduces the time that they need to assemble robots. There are also robots for medical use. Medical and healthcare robots include systems such as the Da Vinci. Wait, excuse me. The Da Vinci surgical robot and bionic prosthesis, as well as robotic exoskeletons. A system that may fit in this category but is not a robot is Watson. The IBM question answering supercomputer has been used in healthcare applications. So these are example. Actually, robots are now used for medical purposes. They are actually suggesting that in the near future, AI capable robots can help in operating, but mostly still they prefer humans, doctors, real doctors, because we are talking about the life of people when operating. So in this section here, as you can see, it also helps in medical field. If you have lost your part of your arms, then you can replace it with robotic arm. For military and security, military robots include ground systems like Endeavor Robotics, PacBot, used in Iraq and Afghanistan to scout for improvised explosive devices, and Big Dog, designed to assist troops in carrying heavy gear. Security robots include autonomous mobile systems such as Cobalt. So there are also robots for military use. This one, um, they call this PacBot. PacBot. Actually, these are useful inten for military purposes. So the we have here tanks. In my college days, one of our higher years, they made a robotic tank machine that is equipped with rifle. So these are military. For research, a vast majority of today's robots are born in universities and corporate research labs. Though these robots may be able to do useful things, they primarily intended to help researchers do well research. So although some robots may fit other categories described here, they can also be called research robots. So actually, it's the same as the previous ones, but these robots are actually used for research purposes. Whatever the data that they want to gather, so they usually use these robots. There are also self-driving cars. I know you're very familiar with this. Many robots can drive themselves around, and an increasing number of them can now drive you around. Early autonomous vehicles include the ones built for DARPA's autonomous vehicle competitions and also Google's pioneering self-driving Toyota Prius, later spun out to form Waymo. So self-driving cars, the example is Tesla. So Tesla has self-driving cars. But try to remember guys na though there are self-driving cars, but you cannot allow the car to drive you around like a city. So it's not allowed. It's not allowed, especially like for our one here, like LTO. If you have Tesla in the Philippines, you cannot just leave your steering wheel without your hands. If an officer see you, that's a violation because self-driving cars are intended as support only. Okay, support that whenever like you'll feel sleepy along the way and you mistakenly removed your hands from the steering wheel. So Self-driving cars can help you with that. So again, from the video I've seen in Facebook, the driver was asleep in the car without his hands on the steering wheel, and it actually went viral. So they have debate about it that though these are self-driving robots, but still there should always be a human intervention when driving, because the car itself is not licensed to drive, but you are the one licensed to drive. Okay, so we have here in the Philippines the non-proof, professional, and we have the code 1, 2, or 3 if you are a professional driver and you want to drive public cars or vehicles. Telepresence. Telepresence robots allow you to be present at a place without actually going there. You log onto a robot avatar via the internet and drive it around, seeing what it sees and talking with people. Workers can use it to collaborate with colleagues at a distant office, and doctors can use it to check on patient. So telepresence. Mostly these robots have cameras in it. So like for example in medical, so this is the doctor and the robot will just roam around the rooms and then check on the patients without his presence. So these are good uses of the robots. Now, we have here underwater. So who would have thought that robots can also dive in the water? Since, like for example, we always think about, maybe it can wet the inside components, so it will not it will like burn out, or it will not function well because it will also be wet in when you submerge it into underwater. Like the favorite place for these robots is in the water. They consist of deep sea submersibles like Aquanaut, diving humanoids like Ocean One, and bio-inspired systems like ACM R5H Snakebot. So these are the example, guys. Okay. So we have robots, actually robots that can already operate underwater. But you and this one can be wireless, but you cannot just communicate it. If you want communications and an unlimited like power supply, you need to have a long connecting wire for these robots. You can see at the back here, this is a wire. Even though you submerge it into water, it's still connected from the surface for its power and for control and manipulation. So we also have this one. So there are a lot of types of robots here. Okay. So again, guys, if we have already summed up that there are a lot of types of robots, you just have to be familiarized with it. Just a recap for the types of robots. We have aerospace robots. We have consumer robots here. We have disaster response robots. We have drones. Here, drones. We have it for education, for entertainment. We have for exoskeletons. We have humanoids, industrial robots, for medical, for military and security, for research, self-driving cars, telepresence, underwater. So guys, do you have questions about the types of robots?
Oh, yeah, sir.
No, sir.
Okay. So, how about Ryan? Okay, nag-chat si Ryan. So guys, those are types of robots, ha? So we're introducing to you robots. Let's proceed with the components of robots. So what are the common things we have for robot? Like for this one, Na siya ay voice synthesis, emotions, embedded CPU and Wi-Fi, LiPo battery here, the power supply, 25 degrees freedom, it can kneel down, 20 degrees, 23 inches, Linux OS. So if you're familiar with Linux OS operating system, so it's the one inside this robot, prehensive hands, switchable head, two cameras, and voice recognition. For robots like in the industrial, so there are things that they consider like U axis, R axis. These axes are the movement of the robot. We have T axis, L axis. If you can what you call that? If you can visualize the letter, so that's the movement. B axis, waves, then X axis, and we have also the controller and the programming pendant. So this is how actually the arm robot works, and these are the movements. Now, main components of a robot. So again, from the previous discussion we have, they have the central processing unit or the CPU. One of the main components of a robot is a main component in any computer-driven technology. The central processing unit, CPU, acts as the brain of the robot. In other words, a CPU is the robot component that provides feedback to outside stimuli. So just like this one, we have here in our system units like the one we call CPU. So actually CPU is the central processing unit or the processor itself, okay? Number two, robots have sensors. That takes us to the next key component to every robot sensor. Sensors are the powerhouse of robots' feedback mechanism. They act like eyes and ears to help the robot take in information about its surroundings. Robots typically incorporate a wide range of sensor types to help them perform their work. These are the examples of sensors, okay? Take note. We have light sensors, sound sensors, temperature sensors, contact sensors, proximity sensors, distance sensors, pressure sensors, and positioning sensors. And there are still a lot of sensors. Maybe we can make this quiz on the next days to come. Like I'll just say, what are the sensors in a robot? So you just have to be familiarized with these sensors. Again, as you can see, robots have like in our humans we have these things, and that's why it's called humanoid, because it can actually act as a human. So sensors, like for example for our sight, so they have sensor for that one, body balance sensor here. For the sight we have CMOS image sensor used in cameras. For audio we have like microphones here, ultrasonic. And for humans, the fluids they can use micropumps and biochips. For smell, they have we have sensor gas sensors and electronic noses. And for like our brain communicates, so there are also RF communication, oscillator, tuner switches. For focus, we have the sensors, autofocus. For the taste, we also have humidity sensors. For speech, micro speakers. So it actually emulates human senses. So pressure inside our body, we have pressure sensors. And for touch, we have force, haptic, and touch sensors. So there are a lot of sensors that can be incorporated to make it like a human behavior already. There are also actuator. If sensors are the eyes and ears of the robot, its actuator functions like muscles. So muscles ang actuators. Actuators are small motors attached directly to the structure of the robot that facilitate movement. Some of the most common types include hydraulic, uses oil to facilitate movement. So we know about hydraulic, right? There are bulldozers. What do you call that? That uses hydraulic. What else? Backhoe. but they also differ from actuators. There are also those pneumatic uses air to facilitate movement, and electric uses electric current and magnets to facilitate movement. For actuators, guys, if it says hydraulic, it uses oil. For pneumatic, it uses air, and for electric, of course, it uses electric for movement. So these are the types. Actuators. Okay? The fourth one is end effectors. Another quality that most robots have in common is end effectors. The terms effector and end effector are sometimes used interchangeably. Both terms refer to the tools aboard the robot. That is, the tools that perform the actual work and interact with the environment of a workpiece. Here are few examples. Oh, dari. End effectors. Okay? Our supply. Just like human beings consume food when they need energy, robots need energy to function as well. Almost all robots receive their power from electricity. This type of power supply is commonly used for CCTVs. But for mostly robots, especially those that are not standby dependent, so they use these batteries inside it. So lithium ion and other types of battery. So from the word, it's a power supply. Okay. Of course, a program. So the robots will not function if you will not put or upload a program inside it. Okay. So a robot's programming isn't a physical component, but it's still an essential part of the whole. Each of the components of robots we've looked at today either takes in stimuli or provides a form of feedback. The program within a robot provides the logic that drives these behaviors. Okay? So I know you've undergone a lot of programming already. So robots need program for you to load information as to what it's supposed to do, those things. Okay? So again, guys, let's recap. Main components of a robot, we have central processing unit or the CPU. We have sensors. We have actuators. We have end effectors. We have power supply. A program, of course. And that actually ends our topic for robotics and intelligent artificial intelligence. Do you have questions, guys? Huh? Questions. Yeah,
I'm
I'm
back.
entertaining questions.
None so far,